So in this video, we're going to talk a little bit about charge and matter and how interactions between charges and matter result in a phenomenon called polarization. So what we have here is a very simplified picture of an atom. It has a positively charged nucleus, which is very dense and very heavy, and a negatively charged electron cloud, which is kind of effuse and very light. This particular atom is neutral, as most matter is neutral, which might make it seem like it's pretty boring, right? There's not a lot that can happen. But if we bring up a lone external charge, right, some positive charge that we're carrying around, what ends up happening is the electron cloud can shift. It can move around a little bit. And so the electrons can spend a little more of their time closer to this external charge than farther away from it. And this phenomenon is what we call polarization. And it gives rise to lots of different kinds of things that we see in nature. But it's this sort of separation of the charge, this distortion of the atom. Now, the way that we represent this in our course is to sort of draw these ellipsoidal figures, which have a negative charge on one side and a positive charge on the other, to demonstrate that the polarization has occurred. The charge is sort of separated out. We actually refer to these as dipoles, electric dipoles. And we'll talk a little bit about that later in the course and why they're important. If we were to bring up a negative charge, we would have the same result, except the electrons would be sort of forced away from that negative charge. We would still have a dipole, but it would just be oriented slightly differently. Now, a lot of these little dipoles can occur together, and this is actually really important and interesting when we're talking about real materials. So there's two kinds of materials that we're going to be interested in. One is the insulator, and the other one is a conductor. So we'll take them in turn here. So in an insulator, we have the property that those electrons are really tightly bound to their nuclei. So they can't move a lot. They can shift a little bit, but they can't just sort of bulk move in some way. So what will happen is if we were to bring up, let's say, a positively charged rod of some sort near an insulating block, we would get shifts that look like this. Little shifts like we drew earlier, where the electrons spend a little bit more of their time closer to the rod, and they sort of leave behind the positively charged nuclei sort of to the right-hand side. So this is the phenomenon of polarization. This is what it looks like when you're talking about an insulating block or an insulating piece of material, because the electrons are really tightly bound to those, so they sort of stay close, but they distort just a little bit. Now, the difference between those and conductors is the valence electrons, the outermost electrons in a conductor, are actually pretty free to move. So those outermost electrons, we can really think of them as almost being free electrons. They can move around a conductor pretty easily. And so when you bring up some sort of positively charged rod, like this, near a piece of metal, a lot of electrons rush over to the side that is near the positively charged rod. They end up piling up on the side. They get as far away as they can from their positively charged cores, but they end up piling up on the outside, and they leave behind these positively charged cores. So the effect here is pretty dramatic, and we'll explore that in some detail.